Good evening. It is a little bit of a quiet night tonight. Maybe people are just kind of trickling in, or maybe they are concerned about the weather, or possibly taking Veterans Day as a holiday. Either way, I have the recording, so hopefully people can catch up if they're not here in class. It is something I'd like to say that I do greatly appreciate everyone who has either volunteered to be in the service or who's supporting someone who's in the service. Our country is much better because of it, so thank you very much for you and your loved one's service. Today's class, we're going to focus on using concentration. I noticed that a lot of people struggled with the homework this week. I don't know if that was a time issue or if that was like the challenging content. It was, 2 hours is probably not enough to do a homework assignment like that.
The time it says on there is a lie. I'm like, multiply it by 2.
Sometimes the time it says on there is a lie. It gives you an estimate so you can gauge. If it's a topic that you're comfortable working on, then the time might be an overestimate. If it's something you're really uncomfortable with, it might be half as much time as you need. So try to at least use that as a gauge, but probably goes without saying, always try starting it as soon as you can, and so you know how much time you might have to invest. The homework assignment for this coming Sunday is open, so you can start that as soon as you want, and you might not get very far if you're not comfortable with acids and bases, or some of the stuff is overlapping with lab. So hopefully you'll start to see it come together as you practice more and you see it in multiple places. Any questions or comments on logistics before we move into class today? Okay. If you have not already, look at the questions up on the board. It's number 1 on your worksheet. I think it was towards the end of our worksheet last class. But I want us thinking about how these concentrations can actually be used to gain information. I saw a few people working on this, writing out the process. Remember, we're going to unpack our concentration units every time we see it. So first step, write out what those concentrations actually mean, and then see how you can use it to answer this question.
Oh, we weren't just supposed to look at it and be like, vodka has more.
Yep. So
it's obviously the vodka.
Stuck on how to do this, check with your neighbor or call me over. We have Sarah and Emily in class today.
175. Negative times 12.
It's the other way around.
If not,
It's the other way around.
why?
Because you're finding ethanol.
Yeah.
So it's divided by 100 times. Oh, well, it's divided by, yeah. Wait, no, never mind. Oh, you're right.
That's still what it keeps.
No, because we're finding ethanol.
That's not taking on like 12 so to make it that the
It's
has
100 times 12. Because,
so are we doing it by proportion that proportionally the vodka is more, or just that one actually has more?
yeah.
Are they trying to just say, like, if you were to extract the alcohol from these two substances? Yes. It's not going to give proportions of this one, proportion.
This one. So it's 175 milliliters of wine. So every 100 milliliters of wine, there's 12 milliliters of ethanol.
It would have been better if the question was carrying 2 ones with 44 milliliters.
That's so true.
This is a lot of misleading.
vein has more alcohol.
My vein.
Not concentration.
All right, can I have a volunteer tell me how we write out the concentration first? So let's unpack it. Bradley?
So for wine, it would be 12 milliliters of ethanol per 100 milliliters of total concentration. So wine.
Great. So every time we see a concentration unit, I promise you, you will be much better off if you rewrite the concentration in the units that would actually be a conversion factor. So like Bradley said, 12%. We know that the units have to be a volume for the solute and for the solution. So 12 milliliters of ethanol in every 100 milliliters of wine, the solution. So then we're going to write the same thing out. Bradley, what would it be for the vodka?
So for vodka, it would be 40 milliliters of ethanol per 100 milliliters of vodka.
Vodka. Close enough. Okay, so now we have two conversion factors. How do we use those to answer this question? Can I get a new volunteer? Sam?
For the first one I did 175 mils of wine over 1 times 12 mils of ethanol over 100 mils of wine.
And I really like that when we initially set up the conversion factor, we used wine or vodka as a denominator, because then if we just say solution, well, we could use either a conversion factor, which is solution. But the more specific we are in our conversion factors, the more it guides us in which one we should use one. So what did you find for your milliliters of ethanol for the wine?
21.2 mils.
Okay, does everyone agree with the sig figs? Dustin, you're shaking your head. Why?
The smallest amount of sig figs is 2.
2 sig figs. So I would say 21 milliliters of ethanol. Okay? And then for the vodka, Sam, you want to go ahead and do that one as well?
Sure. 44 mils of vodka over 1 times 40 mils of ethanol over 100 mils of vodka.
And what'd you find?
18 mils of
I heard some people guessing, they're like, vodka has more alcohol. Of course it does. So remember, it's a concentration. It's a percentage of it. If we had a barrel of wine, of course it's going to have more ethanol in it than a shot of vodka. So we want to think about what the ratio is and the total amount that we have. Those are two really important factors that exist. So based off of this, which one is our larger amount of ethanol? Okay, so today we're going to be focusing on is how to use concentration as a conversion factor. And so we're going to do some biological examples of that. We're also going to do some chemistry, straight up chemistry applications of that. So by the end of today's class, we're going to be talking about how to determine concentration, kind of thinking about what it looks like and what it means. I think that it's really easy to get stuck in this like math brain and to shut down and to have conversion factors and like, I don't know what to do. So hopefully I can help you back out of that a little bit. And then we're going to do stoichiometry today. But instead of using grams or moles as our starting point, we're going to use volume as our starting point. And it's going to be of solutions. So we're going to do a lot of calculations with that. So if we have these 3 cups of urine, let's say that your working in a hospital, you need to collect urine from a patient. Which one of these three has the least dissolved solute in it? And then I want you to explain to your neighbor why you picked the answer you did. Try to be as technical as you can in your description.
There's that stuff in there.
Which one do you choose?
I chose A. Wait, is that supposed to be empty? No, it's clear. Did you got something in there? It's clear. There we go. It's clear. I chose A. Unless that cup is supposed to be empty. That cup's supposed to be empty. No, there's something.
So each one of these cups has 6 ounces of urine in it.
I said read the question. This is why this thing's on the test. I don't read the question one way. Okay. So, can you guys explain to me why you choose that? Okay, but the darker it is, the more solid it is. The darker it is means there's more solid.
I like drinking.
The solute darkens it. It's like when you just took a multivitamin, and then you go pee shortly.
So the lighter it is, the lighter it is,
The lighter it is, the more
has the more.
the lighter has less solute.
Okay, so we have a very interesting distribution of answers. And I'd like to hear some of the conversations that you had on which one you chose, which your group chose, and why. Who'd like to volunteer? Share what their group discussed. Jay?
So you said E, because the way that I understood it was that if, forget the urine, because I don't know anything about urine. So if it was like you put sugar in water and you mix it up, then it should be clear, it should still look like water, or whatever that you put in there, because it's dissolved completely. Or if it's not dissolved completely, you can still see it and it's a darker color. And so
Okay.
I would E.
So when you pee and it's darker color, does that mean that there's less stuff in it? That's what you're saying.
Yeah.
I think you overanalyzed that.
Maybe.
So maybe Dustin, can you ask your question to the whole group? The one you asked me earlier?
I asked if, I'm going to mispronounce this, I asked if there were still precipitate.
Precipitate?
Precipitates.
There's a precipitate. So she was asking if there are solids that are not dissolved, and all of these would be clear liquids. They're clear, but there's different colorations. So the bottom one has the darkest color, the top one has the lightest color. So did the group choose another one, and maybe willing to explain why? Carmen?
We chose A because it's diluted.
Because it's diluted. What do you mean?
It's basically water. In some sense.
Okay. So I think that those two comments represented the discussion from the class, that were almost 50-50, and then someone chose to be cheeky and put the middle. So out of these, if we're thinking about the process of going to the bathroom, we're doing that to excrete unwanted products from our body, right? Metabolites and waste products. So if we're doing that, what's it going to look like if we have no dissolved waste in our urine? It's going to look like water. If we have a lot of dissolved stuff in there, it's going to be a much darker color. So for this one, the one with the least dissolved solute is absolutely A. And so this actually tells us a lot about the person and how much fluid they're taking in. So if you have someone who is drinking a decent amount of water, then their urine should be this color, because that means the solute is being flushed out. It means you constantly have water going through and pulling those things, washing them out of your body. If you drink too much water, which is definitely possible, your urine's going to look like this. And yeah, it's probably not healthy either. your concentration of solute is so low, you're putting mostly just water through your kidneys, and you're having them work a lot harder because they're constantly pulling water out of your blood.
No electrolytes.
But on the other hand, if you aren't drinking very much water, or you've exercised a lot, right, and you sweat out the water, and you don't have as much to flush it out, you're still going to have the same amount of garbage that you're trying to get out of your body, same amount of compounds, maybe even more if you're exercising, but you have a lot less liquid to put it in. So I want us to think about visually, there's a lot of assumptions I'm kind of making here, and that there's healthy people, and it's just based on the amount of water you drink. But the more water you drink, the more dilute your urine is going to be with essentially the same products, and the more you're going to have a clear solution. So concentration is this idea that if it's, going back to Jay's point, in chemistry, a lot of our compounds when they dissolve are clear. So this analogy is more about the concept behind it. If you can see the color, it's like, oh, I can tell that there's more in the same volume, more solute here. If it's sugar, we can't see that. We could taste it. We could use other forms. So there's a lot of ways to analyze a sample. You wouldn't taste these, but you would taste sugar in water, and the more sugar there is dissolved in the water, the sweeter it would taste. And so we could analyze it that way. And in chemistry, in your labs, what are you doing to analyze how much is dissolved in water?
Measuring the, never mind.
What are you doing in the lab this week? A what?
The actual volume.
Titration. So titration is a way to say, well, we can't necessarily see how much is in there because it's a darker color, but we know that something's in there. So let's do a chemical reaction and use up everything that's in there. Once we've used it up, we're going to see a change of some sort. pH, color change, we're going to do something, right? So your lab this week is a titration, which is one of the ways to analyze what's in solution. So let's see if we're on the same page. Which one of these has the highest concentration of solute? Solutes. There's multiple ones. We did just discuss that, but I want to make sure that I didn't lose anybody. So don't be cheeky.
We want one of those drops. We put it into the thing.
Okay, closing out.
Wait, no.
It turns pink when it goes in.
It lost me out. Wait, just different.
It turns pink when you
Perfect.
are
I will keep Carmen out. You got it?
I did.
Okay. All right, we're all on the same page here. So the one with the highest concentration of solutes is the bottom. So then let's take that and let's apply it. I guess before I do that, does it really matter what units of concentration I use? If I said the highest concentration in milligrams of solute per liter of solution, or I said what's the highest molarity, is that going to change your answer to that last question? What's the difference between those different statements? So if I said this is the highest in concentration of percent mass to volume, or the highest molarity, does that make it a different statement? Why not, Donald? So molarity is... So the solution is going to be the same no matter what, right? It's just how we're describing it. It's like saying, I weigh 180 pounds. That doesn't change if I say I weigh 78 kilograms, right? So it is a description of a physical property of it, and we can use different units if we want. I could say how heavy I am in ounces. It wouldn't change how heavy I am. So the concentration won't change no matter which concentration value you use. We just might have or use a different one based on our experience. So let's say that you're going to be in the medical field and you're doing some sort of drug testing. You're related to someone who's doing drug testing. Would all of these samples be equally as good for drug testing? Submit your own answer first, and then check with your neighbor.
I said you drink so much water, the hydroponic.
drink more water to hide the fat in you. Everything going on today.
Was it a government job? Yeah. Even our nurses.
All right, can I have someone describe what your group discussed on this? I heard some good conversations going on in different parts. Sarah and Robbie, would you like to describe what you guys discussed?
We said no, because more concentrated is going to have more of what you're testing for in it, and the top, the more hydrated, it's not as many the particles you're testing.
So in order to get this one to look like the lemonade, the burnt orange to look like the lemonade, you could make that happen, but you'd have to add maybe 6 parts water for every 1 part of the urine. So you're diluting out this drastically when you get to here. And if our drug tests are based off of an acceptable amount in the urine, right, there's a limit of detection or a cutoff. If you're expecting one of these two, but you're testing this, you're going to get a much higher reading than you would if you were using one of these two. What about this one up here? So if you are the person in the lab that actually is doing the testing, you get urine that looks like that, what would you think might have happened?
They're hiding something.
Either they're drinking a ton or they're hiding something. How would they be hiding something? So they might have added liquid to the collection cup after it was collected. Right? So there's a ton of different ways they try to protect for that. But those are some ways that people try to get around drug screening if they have been or are concerned about a positive result. So this one, is it more likely you'd have a false positive or a false negative? False positive is likely because you're going to have it show up. Even if you had a trace amount in there in the person's bloodstream, you're going to concentrate the heck out of it, so you're much more likely to get a positive out of this one. This one, you're much more likely to get a false negative. So thinking about how much dissolved in a certain amount of volume, and then how the test is run. So I just wanted to go through that to kind of get us thinking about what concentration means, trying to picture the ratio of solute to solvent in a solution, and hopefully we can take that and just apply it to a whole bunch of other more technical things. So let's see how we do on this one. Going back to Jay's favorite compound, talking about some sugar here. Which one of these has more glucose dissolved in it? Please try to show your work kind of like we've been doing. It means we're going to write out our units of concentration.
Multiply these two things. And
So
then I can do
what is
the-
your non-competitive use that on the first page?
Like, how would I do manipulate it? Multiply the two of them, then put that in there.
What is your non-conventional factor number? Start with it. The one that only has 1 unit on it. What does the big M stand for?
Molar.
inches. Moles per liter. So which one of those three only has one unit? Liters, moles per liter, grams per mole.
That one, whatever.
Write that one down first. Alright. Alright, so how do you go from liters of that
Could just.
to moles of that?
So just,
We're going from moles to grams. You don't have to do this step. It's the other two you need to do step 4. Very step 2. You don't need to step 4. That one. You already got your moles. What you're trying to do is turn them all into moles. So solve that one.
it's just, I have no idea what to do. Oh. Okay.
Now the next one. Non-converting factor first.
Okay, so you find the one that doesn't have, that's just one thing.
That's 1 unit.
1 unit. That's that.
Okay. Right.
That's right.
It's in what?
It's in milliliters.
So I need to turn it into what? First. Okay.
So I think she's got Hey.
Alright. So from liters of that to what is this now?
Well, that's over mils.
Yes. So rewrite this. What is this? 25 what per month? There we go. Alright, and it's going from grams to moles, alright?
Even though it's a higher concentration, it has almost half as much
So he has
in grams.
There you go.
And then after I get that, I can turn it, 5,000. That's been
No, it's gonna be a mole. Just go from milliliters to milliliters to grams.
Calculations, it already makes
No, not in this case, because you're not using malaria, you're using mass percent.
and then like, sometimes it's tricky.
You're gonna see these two.
But this one still wins out by like what?
No, you're gonna see mass per volume, mass percent, and volume, and mass per mass volume. You'll see those two. Actually, mass, this one's right here.
That does, yeah, grams.
Because you're gonna see a lot with safety.
Yeah. That one. Oh, no, I can wait. No, I'll start with that. So then, no, I won't. Yes, I will. I'll do 31. Yeah. 100 mils.
Remember, this is 379 grams of solution. So what's going to be on the bottom? 100? It's solution.
Wait, this mass per mass, is that not solids?
Yes.
So I put 100 on the bottom?
At a large number. No, 12,200.
Then you go to grams. Because this is and you're starting with 379 grams of a 31% solution. Cancel out the grams.
Okay. Oh, thank you. Yes, this homework was tricky for me just because
It's
I
technical.
didn't really know where to begin.
It's technical. There it is.
Boom.
So which one has the most glucose dissolved? Okay, now let's do this one. Alright, first, you don't have it.
That's got 2 things. That's, we need to completely consume this.
Do the next one.
Okay. We have about the same proportion of the class that replied to this question as completed their homework. So I'm imagining there's a correlation between those. That getting up to speed and using concentration can be challenging. So let's go through the steps that I urge everyone to do each time. If you remember on the back of the worksheet from last class, I gave you what the standard units are for each of the types of concentration we're using. So let's make sure to always reflect back on that if we need to, but hopefully we'll get more comfortable using it and know what to use when. So let's start with the first one. Do I have it on a different order on your worksheet? Yes. I do. Okay, we're going to start in my order because I have it in that way for a reason. So first, 749 milliliters of a 23% mass to volume solution. How do we write that out as a concentration? Chris?
23 grams of glucose over 100 milligrams of solution. Oh, milliliters, my bad.
Okay, so when it's mass to volume, this is the only one where we're super strict out of the percents. It's always going to be mass in grams per volume in 100 milliliters, right? Percentage means out of 100. So it's always going to be per 100 milliliters, and it's however many, I don't know why, grams of glucose. What are our other conversion factors? Can I get someone else to tell me how we would write out the conversion factor for 31% M over M? Shelby. Over 100. Okay. And our last one, which was your first one, I believe. Can I have someone else tell me what those units are? Crystal, you want to?
0.55 moles of glucose over 1 liter of solution.
Great. If I was really into numbers, I'd force you all to convert to write out C in each of the other types of concentration units.
What?
You can do that, right? You could say, well, this is a concentration. What if I wanted to report this one as grams per 100 milliliters of solution? We could do that. It's just another set of units we're using. But I'm not as interested in you doing that as having you use and understand them. So, let's go to the first one then. if we know that that first solution has 749 mils of a 23 mass to volume percent solution, how do we actually calculate how much glucose is in that solution? Andrew? You want to?
Good question. So we start with our 749 milliliters over 1.
What's the 749 milliliters of?
Total amount of solution.
Great. And then?
We do our 20 grams glucose per 100 ml.
Fantastic. So if we're thinking out loud, we're going to say, well, for every 100 milliliters of solution, we have 23 grams of glucose. We have 7.5 times that much, so we're going to expect to have, I don't know, over 100, almost 200 grams of sugar. So let's keep that in mind, that ratio should tell us something. And then, give us a little more space. Are we done? Do we end there? We can. That's cool. So does anyone have a value they want to give us?
172.27, but I didn't do 6 figs. That's what I got, but I didn't do 6 figs. Oh,
What is it?
grams of glucose.
Great. So let's not worry about sig figs for right now. Does that sound about right for how many grams of glucose? Okay. Can I have someone walk me through the second one? Chris, nice and loud.
379 grams of solution over 1 times 31 grams of glucose over 100 grams of solution. Equals 117.49 grams of glucose.
Okay, so out of those two, can we answer this question so far? What is the most total dissolved glucose so far out of those two? We have a pretty clear and obvious answer because we're comparing grams to grams. One of the things to keep in mind is the mass to mass ratio. Most commonly we'll say how many grams, 31 grams out of 100 grams of solution. But this could be pounds to pounds. It could be any ratio you want as long as you're using the same unit. In this case, it makes a lot more sense to use grams because the other ones are going to be in grams as well. All right, can I have a third volunteer for the last one? How do we find out how much glucose is in that last sample? Okay?
So we started with 1.24 liters and multiplied that.
Can we be a little bit more specific?
I'm sorry, over more.
Even more specific? 1.24 liters.
Oh, I'm sorry, a solution.
Great.
And multiply that by 0.55 moles of solution. Or no, it's glucose?
Which one?
Glucose.
It's a solute glucose. Okay? Per
1 liter of solution.
Okay, and once again, just thinking logically, for every 1 liter is 0.55 moles. We have slightly more than a liter, so we're going to have slightly more than 0.55 moles. Are we done? We can stop. We know how much glucose we have, right?
No.
We know how many moles we have. So why can't we stop?
We have to get it in grams of glucose.
Why do we have to put it in grams?
So we can compare it to the other two.
Fantastic. Okay? So what do we need to do to get from moles to grams?
So then you will multiply by 180 grams of glucose over 1 mole of glucose.
Okay? And what did you find for your grams?
I got 122.76 grams of glucose.
Fantastic. Okay, and then we can worry about sig figs, but honestly, to answer this question, I don't think the sig figs are going to play a role because we have 3 sig figs for all, which should give us to the 1's place. Actually, do we have 3 sig figs for all? I lied. 2 sig figs, 2 sig figs, 2 sig figs. Because the concentration units are only 2 sig figs.
You don't do it from the first one?
It's whatever limits it. The smallest accuracy is what's going to limit your answer.
I always thought it was with the first number.
Nope.
So if we were taking sig figs into consideration, we would have to do all of them in scientific notation?
Yep, we'd want to do all of them in scientific notation. So 1.7 times 10 to the second, 1.2 times 10 to the second, 1.2 times 10 to the second. So we might not be able to distinguish between the second and third as far as the amount of glucose in those samples, but we'd have a winner by far on the top one. All right. Questions? Y'all are very quiet. Is this like, yeah, I got this?
No, I mean, let's keep doing it.
We're not going to keep doing this exact type the whole class, but we're going to do some other things related to this. Yeah, we're going to hone in a bit more. All right. So let's take that and amp it up a bit. And I want you, if you get stuck, when I was walking around, I saw a number of people who didn't have anything written down until I got there, which was like 5 minutes into it. Please, if you get to that point where you're really stuck, flag one of us over. We have 4 of us now. So we have Akia, Sarah, Emily, myself, and we have Anil. So there's 1, 2, 3, 4, 5 of us. So go ahead and try to figure out how you do this on your own, and then flag one of us down if you get stuck and the person next to you can't really help.
What is the first one you're getting?
My eyelashes hate me. Every day. Every single day. My eyelashes just go straight in my eye. It like never stops. Never in existence is pain. awake, but at what cost?
Good job. I don't know if I did right.
It is what it is. I just don't know what I'm trying to talk about.
I think I'm going to.
I don't know. I have to check it out.
Now all we need to do is convert the grounds to milliliters of hydrocarbon acid, which is first using the concentration. We'll have to talk about this first by using the molar mass, converting it to moles, and for moles using the ratio of 1 to 1 to moles of hydrochloric acid. Use the concentration using
I don't read this word. It's not a picture. They're set. Start over.
Oh, yeah. What do you got?
I went from Graham.
Isn't hydroxide just a negative?
That's the part that I told you. This is the answer to the
If it had just been potassium, I think I would have gotten more of those.
I calculated out to 6.105 per rate.
What's
solid.
Is it okay if I make a plan tonight?
Yes. Just make sure you come in next week, because that's the last
Yeah,
one.
it's the last one before the mock exam, which is
That will be Thanksgiving week. So your final exam will be the week after you get back from Thanksgiving.
okay, so
Next week, all you're going to be doing is you're finishing up the ceremony.
okay. And then
Then you're going to pack up
after considering
your final from me.
yeah.
because we're doing the final in the lab. We're trying to do it.
December 2nd or December 1st?
And we'll be doing check out the drawers, survey, and final. We have 3 hours in there. He's only like 1.5 hours.
You know, final just on pretty much everything we covered in lab files, the actual experiments.
Yes, I'm pretty sure probably tomorrow.
Oh, yeah, there's the
The mock exam. And it's basically just kind of pick and choose like pre-lab questions, post-lab questions. That's stuff that you will see on the lab. So we've already made a lot of they need to know that they need to put it down.
All right, crystal clear? Good to move on?
Yes.
Sorry, was that not funny? That's why everyone's very quiet. Okay. So let's go through this and talk it out. What have I been saying is the very first step anytime we see a concentration unit? Unpack it. Write it out. So we have a concentration unit here. We know that that is 2.75. What are my units on top? Moles of HCl in every 1 liter of solution. So basically what we're saying is we have this pile of potassium hydroxide, and we're adding to that in a beaker. We're adding some liquid, and that's HCl. How much HCl, what's the volume of HCl I need to add in order to make all of that potassium hydroxide go away in a chemical reaction? So what's the next step I might need to do to answer that question? Brendan? So where do I go from here? How do I start this? You want to pass? All right, who wants to help out? Jocelyn? What kind of equation? Okay, so the reaction, chemical reactions that we're talking about? Fantastic. So what is that? Okay, so we knew it was a neutralization reaction because it was in the wording here. So that's an acid-base reaction. So those usually produce water and a salt. Double displacement reaction. So this is what it looks like. It's really important that we write this reaction out because if we don't, we're going to get stuck later down the road. Okay, now I think we have all the basic information we need. So then, Jocelyn, you want to keep going on what we would do next? Why? Okay, so technically it's a molar mass because it's per mole. Molecular weight would be per molecule, but very close. Why would you multiply it by the molar mass? Great, so we started with how heavy is it, but we want to know how many there are, because this equation is how many to how many. Great, so now we know how many potassium hydroxides there are in mole.
And that is 1 mole of HCl times 1 liter of HCl over 2.75 moles.
Over what was on the bottom?
2.75
Of
and then I multiply that by 1,000 liters.
what were the units in the bottom? 2.75 moles.
So you see it?
Great.
And then I do 1,000 milliliters over.
And what did you find for your answer? Did anyone do something differently or have questions about what she did? So how many sig figs should we have? Limiting sig figs is our concentration. So I agree. We would remove that 0, so 28.3 milliliters would be the right number of sig figs. Does this seem familiar? The process should seem a lot like when we were doing stoichiometry. What's the only difference?
It's harder.
Okay, it might be harder. But what's the main difference? In the end, instead of saying how heavy is the HCl, usually we'd use molar mass here. How many grams of HCl? We're saying, well, instead of going from moles to grams, we're going from moles to liters of solution. So all of our concentrations could be put here as long as they're in the right unit to convert between. Want to practice some more?
Yes.
Okay. All right. Have a good night, Tay. All right. Let's go ahead and flip over the backside. And I should have looked at this sooner, but we have 28.3 as one of our major answers. Okay. So let's go ahead and work on first question on the backside. What is the first thing y'all are going to do?
The equation.
Unpack the units, and then you might write an equation. But always, if you see a big M, please write it as moles of solute per liters of solution.
This one's called Ferris. No, yes. Something. Copper. In Latin, it's an Italian chemistry. Or strong. It all sticks back to these.
Anyone know nitrate? Is it NO3?
Nitrate.
Yes. Okay.
What was it?
NO3.
That's right, it's NO3. I knew it.
And what's the charge? Minus 2.
Isn't it just
I'm
like,
actually not sure.
I got it right here.
Oh, shoot.
It's just negative.
No, iodine does not have oxygen.
And then there's lead.
NO4.
Different. Oh, this one says here it's 2. Okay.
NO4 should just be doing
I was right. I was right.
my bad.
Can't move that, I had to put that two in front of there, what if that one, that two, wait. Yes. There we go. In front of here.
Okay. So when you make, well, first of all, what's the charge of the lead? Charge of 2, right?
Sodium.
The charge of iron. The charge of iron.
Nothing?
One, right?
Yeah.
So how many of them do you need?
I only need one.
No.
One.
Remember, lead doesn't change from, its charge doesn't change from here to here. Lead's charge doesn't change once you specify it.
Yeah.
So where does your other 2 need to go? So one more 2 needed. If I have 2 I's and 2 A's, I need, there you go.
Okay.
So which one of those do you think is unvaluable?
That's not saying there's two of those. That's just a charge. So I don't need to take, well, I know, but no, there is two of them. I put that two there. I got the two. I got the two. Okay.
Is I will die. On the board for your turn.
I was gonna say, it's insoluble.
Yes.
Because it's lead.
Okay, so that's the one you're looking for. You good? It's asking for how many grams.
So this is aqueous.
Frustrated.
Okay, that's really solid. So that's my first thing, because you said to take the one that has
I don't even know if it's right.
Lead nitrate. Nitrate. And you're going from that to grams of
Okay. I want to go slowly. This may take me a little while.
Okay, so you're going from milliliters to milliliters, right? And you go from liters to milliliters. How do you do that? And then the milliliter converter.
For what reason?
You know,
It exists to cause me pain. Eyelashes exist to cause me pain. Oh, it's in my eye.
I would just wait. It's already started to pop up just right on my phone when I do it. I do. Look, I don't even have to do it.
it does.
It does.
Oh my god.
Let's see what I get. This is getting a little bit easier with time.
What did you do?
Hey, is that your percentage?
What?
In a, I think that's your percentage. Is it? What's solid? So what's your solid? I'm going.
Oh no!
Right. So I'm not supposed to. I don't know.
You're precipitant, right?
I'm never gonna know.
An eyelash in my eye.
Yeah, that's yeah. But, what translation?
Well,
So always write that down. Don't write big M, because big M means stop with the solid produce.
Yeah, I just erased all the, I didn't need to convert it, did I?
That's a 1-to-1.
And so it's excessive sodium nitrate, so I mean,
Per, what is molarity?
it's just because the lead is
Not 100 milliliters.
then that's the one that
Replace salt with appropriate salt. And then hold your doodling until after class. You should definitely do it.
I need to stop right there.
What's your precipitate? What's the one that forms your solid? That's your precipitate.
Oh, crap.
All right, I think a lot of people have gotten a start on this. So how about let's walk through it, and then we'll have time for one more. So hopefully we'll have some practice. All right, can we have starting points? How do we get started on this? Can I have some new voices? Kisa, we haven't heard from you today. Would you like to share how you started?
Oh, man, sure.
You can pass if you don't want.
I started with 855 mils of lead nitrate. And then I rolled to...
Before you get into all the math, were there some steps that maybe I wanted you to do first?
Oh, man. Well, I converted the molarity to a conversion factor.
Fantastic. Okay, so what would that conversion factor be?
0.25 moles over 1 liter.
And I saw almost everyone I went to, I think, had about this as your conversion factor. What did I ask those who I saw to be more specific with?
In this case,
You didn't see me, but I assumed the top should have moles of solute.
Great, the top should have moles of solute, and I want you to be as specific as you can in each problem. So in this case, it's PbNO3 2. So actually write in what the solute is, because then we start looking at your equation, you say, okay, that's what I can use it to convert from moles to liters of. Okay? And then, do you do anything else before you did all your math, Gisa?
Oh, man, I wrote it out.
What?
The equation.
The chemical reaction?
Yeah.
Great. What is it?
PbNO3 aqueous plus 2 NaI aqueous arrow to the 2 NO3 aqueous plus PbI2 solid.
Okay. And it's really important to write this out, because if we weren't, we wouldn't know what we're trying to find the mass of in the end. I said, what's the mass of your solid precipitate that you form? That's it. Okay, so that's where we're trying to go. So on the far right side, we want to know grams of PbI2. Okay, now you can go ahead and start with your math. So we started with initial volume of lead nitrate.
Yep, and then I converted that to liters, so 1 liter on the top, 1,000 mils on the bottom.
Okay.
And then I used my conversion factor for the molarity of the solution and put 1 liter on the bottom and 0.25 moles on the top. And this is all of lead nitrate. And then I converted from lead nitrate to lead iodide, which was 1 mole to 1 mole. And then I converted the moles of lead iodide to grams of lead iodide.
Okay, and what did you use to do that?
1 mole lead iodide on the bottom, 461.01 grams of lead.
461 point.
0.01 grams of lead iodide on the top.
Does that sound right?
Is that right? Oh, okay.
And then what did you find
got 98.5 grams of lead iodide precipitate.
Is that what you had as well? Okay, so if we go through every step here. So Kisa started with the volume of the solution of lead nitrate. She converted from milliliters to liters of solution, from liters of solution of lead nitrate to how many moles of lead nitrate, from how many moles of lead nitrate we have to how much lead iodide we could make, and then we wanted to find out how heavy is that. So a whole bunch of steps, but this all hopefully is kind of reinforcing our ability to do stoichiometry. We just have a new set of conversion factors now. That's a lot of times we go into lab and we get a solution instead of a solid. So this is how we do those calculations. All right, we have time for one more.
We have at the time.
All right. So I want to know, let's go ahead and do question 8 on the back. If you don't have time to do the calculations, go through the steps. Set it up the way that we've been doing the rest of them, and flag one of us down if you get lost in the initial steps. We have 3 minutes to set it up. Maybe 2. And as a reminder, aluminum is always +3, zinc is always +2, silver is always +1. 3, 2, 1. Even though they're in the middle.
Doesn't look like it.
So we have kind of no time left in class. Would you all like to have someone talk it out so you could have some notes to look back on, or what would you like? Would you like to just work on your own?
5 more
I mean,
minutes.
what's that? Put up the process, not the answer. Would anyone like to read it out? Ankar, would you like to read it out?
Give it 5 minutes.
No soup for you. Never mind. Seinfeld reference. It's a TV show.
He's 5 minutes.
Go ahead, Tay.
So, I said I impacted it by 0.575
of silver nitrate over 1 liter. And then the equation was silver nitrate plus sodium chloride yields. Oh, I didn't write the stages. Thank you. It yields silver chloride solid plus sodium nitrate aqueous. And so I started off with 259 grams of silver chloride over 1, multiplied by 1 mole of silver chloride over 143.32 grams of silver chloride. Silver chloride.
Oh, sorry. I'm just not thinking. Thanks.
And then I did the molar ratio, so 1 mole of silver nitrate over 1 mole of silver chloride. And then multiply that by 1 liter of solution, so of silver nitrate over the 0.575 moles. And then I wasn't sure if I had to convert it to milliliters, but I stopped at liters.
So this problem doesn't specify liters or milliliters. You probably use whichever one's appropriate. What did you find?
So I got 3.14 liters.
3.14?
Yes.
So would this be a better answer in milliliters or liters? Liters makes good sense. And that's of AgNO3 solution. All right, so I intentionally put more problems that we'd get through in class today on the back here so that you would have problems to practice. Mastering doesn't have a lot, so here's a couple. If you're able to come to office hours, or I have the Zoom link sent out, so use that Zoom link to join us if you're available, even just to listen. You can just click on the link, then you can listen in to what we're talking about. If you want to chime in, you can. Make sure you're muted if you're just listening in and you're not talking. And if need be, I can post some more questions. On Wednesday, we're going to start doing acids and bases, so we're going to transition past this a little bit. Thanks, y'all, for your patience.
Thank you.